Hey guys, so let's solve some log equations. So we've already actually done this a little bit in our workbook. There was one page where we had some log equations, and all we did was we took them and we converted them into exponentials, and then we solved the same way we solved exponential equations. So this, we're going to look at the same kind that we looked at already, but then 3 other new types. So here's the basic form of the 4 types that we're going to look at. So we're going to have log equals some other log. All right, so log of something equals log of something else. And then we're going to have log equals some number. This is similar to the ones that we've already done in the workbook, but they're a little bit souped up, and so we need to kind of clean them up first before we can get them to this specific form. The third type that we're going to look at is log plus or minus some other log equals a log. And then the fourth type is log plus or minus some log equals a number. Oops, I keep forgetting to write that. All right, so those are the 4 types. Log equals a log equals a number, a log plus or minus another log equals a log, and a log plus or minus a log equals just a number, right? So you need the worksheet that I asked you to print out. It looks like this. And before we do anything, we need to get set up here. So I would like you to do something for me. So the first thing that we need to do is identify which of the 4 types we're talking about in each of the problems. I think you can probably figure it out, but just so that you have a reference when you go to do your homework, I'm going to ask you to label them. So for problems number, let's see, I'm going to read them slowly, and then I want you to do this. I would like you to put a box around the numbers for problems 1, 2, 3, 4, 5, 11, so like going down here, 11, 12, and then on the back side, 13 and 14. Again, let me say that one more time fast. 1, 2, 3, 4, 5, 11, 12, 13, 14. You should put a square around the number here, just so that you can identify them all as the same type. Those are problems that are log equals log, and you can see that. There's a log on this side, and it equals a log on that side. All right, next, for problems 6 through 10, you're going to put a circle around them. So 6, 7, 8, 9, 10. I only did it for the ones that we're going to do together. But for 6, 7, 8, 9, and 10, you should put a circle around them. All right, so let me just do that so that you can see them, 6, 7, 8, 9, and 10, but we're just going to do these 2 right here. The reason that we're doing that is because it's a log equals a number. Again, we've got this thing here that we've got to take care of, but in its most basic form, it's going to be a single log equals a number. And again, we've got this -10 to take care of, but once we do, we'll have a log equals a number. Log equals a number. Once we move this, we're going to have log equals a number, log equals a number. All right, so 1 through 5 and 11 through 14 have the square, 6 through 10 have a circle. All right, the next ones that I would like you to do are all on the back. So let's flip over here. All right, it's going to be problems 18. I want you to put a heart around these. 18, 20, 21, 22, and 25. All right, put a heart around 18, 18, 20, 21, 22, and 25. All right, and again, if you look at them, it's, as I said, it's log plus log equals log. Log plus log equals log. Whoops, sorry. Log plus log equals log. Log minus log equals log. Log minus log equals log. Log plus log equals log. So all of those have that same form where it's 2 logs either added or subtracted, and they're equal to a log on the other side. All right, and then the last set is anything that's left. So that would be problems 15, 16, 17, actually, sorry, I want you to put a triangle around those. So for problems 15, 16, 17, 19, 23, 24, and 26. Those all should have a triangle around the number. Again, the reason that I'm not doing that for all of them is so I remember the ones that I want us to do together. All right, so if that was too fast for you, rewind the video and watch it again. All right, that's one thing I need you to do, is so that when you're doing the homework, if you get to a problem that's a triangle and you can't remember how to do it, go back and look at another triangle that we've done so that you can see the steps and then you can recreate it on your own. All right, the second thing we need to do is to go back to problems 6 and 9, and I want to have you fix something for me. The way this is written right now looks like this is log base 7 minus 2r. Right? That's not possible because remember we talked about in class that it has to be log of something. So this something that it's taking the log of is actually negative 2r. So just so that it doesn't look like subtraction, I'd like you to put that in parentheses. So now it's a little bit more clear that it's log base 7 of negative 2r. And then I need you to do the same thing in problem number 9. All right, this is even worse. All right, this looks like log minus m plus 2. And so because there's no parentheses, it's questionable, is this of negative m plus 2, or is it of just negative m? And the answer is, if they wanted it negative m plus 2, they would have had to put parentheses around it. Notice that in every other problem where there's two things, there's parentheses around it. If there's only a single thing in there, they can decide to put parentheses or not. But again, I'm going to ask you to do this because otherwise it looks like log minus m, which just doesn't make sense. So those two need to be fixed. Okay. So then let's take a look at a couple of these, and then I think I'm going to have to start another video because I'm not sure that I'm going to be able to fit all of these problems in. All right, so we are going to do problems 1 and 2 first, and again, this falls in the category of log equals log. All right, now in the last video we talked about functions being one-to-one. And this is going to play a role in here because, well, let's solve one first and then I'll explain why it's important that we know that it's one-to-one. All right, so we have log of 5x equals log of 2x minus 9. All right, so what we're going to say is, well, no, we actually have to talk about one-to-one right now. The only way that I can take log of something and get log of something else is have them be equal is if these things are equal. Because again, remember, we said that logs are one-to-one, which means that if the y value that comes out, again, this is the y value and that's the x value. If the y value is equal to the other y value, all right, so this y is equal to this y, because log is one-to-one, that means that the x values, not necessarily this, but this part, had to have come from the same thing. There is no way that I could get these two logs equal to each other, these two y values equal to each other, unless they came from the same thing down here. All right, so because log is one-to-one, I can say that since these two whole things are equal, then the thing I was taking the log of must also have been equal. All right, again, we can't do that for other functions that are not one-to-one, but we can do it for any function that is one-to-one. All right, so now we've just made this problem super easy because this is just completely algebraic. So we're going to subtract 2x from both sides. We get 3x equals 9. We divide both sides by 3, and we get x equals 3. Now, if you remember from the last video, we also said that because log has restrictions to its domain, we must check to make sure it doesn't violate the domain. So you could take this to mean two different things. One is I can plug it back in and see what I get. So this says that log of 5 times 3, which is 15, should be the same as log of 2 times 5. I'm sorry, no, 2 times 3, which is 6, plus 9, which is 15, and that checks off. The other thing we could say is we're just checking to make sure that when we plug it back in here, we don't get a 0 or a negative number. Right? If we do, then that violates the domain and that's actually an extraneous solution. right? I don't think that there are any like that on this worksheet, but there definitely are in the homework. So please don't forget to do that. All right, so this truly is the solution to this problem. All right, how about you try number 2 on your own? Okay, so you should have gotten log of 10 minus 4x equals log of 10 minus 3x. If these two logs are equal, then that means I must have been taking log of the same thing. So that means 10 minus 4x equals 10 minus 3x. I'm going to add 4x to both sides and subtract 10. You can do that in 2 steps. I'm just going to do it in 1. When I do that, I get x equals 0. Right? Don't panic. Again, it's okay to have an x value that's 0 or negative. What's not okay is when we plug it back in, if that makes one of these two things 0 or negative. So let's check. So if I do 10 minus 4 times 0, I get 10. So I'm taking log of 10. That's allowed. So this becomes log of 10. And then log of 10 minus 3 times 0. Right? 10 minus 3 times 0. 3 times 0 is 0, so 10 minus 0 is 0. So again, we've got log of 10, all right? And they're equal. So don't just automatically assume that if you see a 0 or a negative number as your answer that it's automatically extraneous. You must plug it back in and make sure that it doesn't make these things 0 or negative. If it does, then it's extraneous. If it makes it something like 10, like it did here, then it's fine. Okay, so that's all we're going to do with the log equals log. Pretty straightforward. All right, we're going to try 2 of each type, and then you're going to do some of these on your own. Okay, so the next 2 I would like to look at fall in the family of log equals some number. And again, this is similar to the problems that we already tried in the workbook, except there are extras around here, all right? So in this problem, there's a coefficient of a 2. In this, we've got a minus 10 out front. So before we solve this, what we have to do is get rid of those things, right? So there are 2 different ways to get rid of that 2. I'm going to encourage you just to divide both sides by 2 and get rid of it. You could put it back up here as an exponent, but that just makes a little bit more work. So we're going to write this as log base 7 of negative 2r equals 0 divided by 2 is 0. All right, now we're going to rewrite it as an exponential. All right, so that says, well, we take the base here of 7, and then we flip-flop these 2. So it becomes 7 to the 0 equals negative 2r. Well, what is 7 to the 0? 1. So we have 1 equals negative 2r. And then we solve for r, and we get r equals negative 1/2. Now, we plug it back in to see, does this violate the domain? Does that make this 0 or negative? So I've got 2 times log base 7 of negative 2 times negative 1/2. Is that equal to 0? Again, there's 2 parts to this. One is checking to see if you violated the domain. One is to check to see if it's actually the correct answer. We're just checking to see if it violates the domain. So negative 2 times negative 1/2 gives us positive 1. Right. Now we could just say divide both sides by 2. Actually, we would probably have to do a little bit more work here and say is log base 7 of 1 squared equals 0. Well, that's log base 7 of 1. Is that 0? Is 7 to the 0 equal 1? Yes, it is. Right. I'm more concerned about this step right here. All right, making sure that when you plug that r value in here, you don't get 0 or negative. If you decide to check it to make sure that it's correct, that's fine, but really I need you to check to make sure it's not extraneous. Okay, let's do this one right here, and then I'm gonna pause and start a new video so we don't run over our time limit. Okay, so again, we've got this extra here. We're solving just like we would an algebra equation. We're trying to get the variable, which is right here, by itself. And so what we're going to do is we're going to bring this negative 10 over to the other side. So I'll add 10 to both sides. So then I'm going to end up with log base 3 of n plus 3 equals 0. All right, now that I have log equals a number, I rewrite it in exponential form. So this becomes 3 to the 0 equals n plus 3. 3 to the 0 is 1, so 1 equals n plus 3. That gives me n equals negative 2. Again, we're not panicking yet because we just need to see if that makes this negative. But when I plug it in, I get log base 3 of negative 2 plus 3. That is fine because that becomes a positive 1. Right? But if it had been something like negative 5 that we got as our solution, that would be a problem because then we'd have negative 5 plus 3 is negative 2, and we'd be taking log of a negative number. So since that became positive, that is the solution. All right, I'll be back in a minute.